Okay, so we said operational definition means is a precise description that tells you how to get the value for your characteristic. Or we use the word characteristic now, or we use the word parameter. Okay, these are the two words that we must understand in Six Sigma. What is that exactly that we are going to measure? It includes what something is and how to measure it. Okay, it removes ambiguity so that all people involved have the same understanding of the characteristic or feature in question. And it describes the way that you measure that characteristic or feature. So characteristic can be anything. It can be, like you say, if you take pizza, for example, the characteristic may be the number of defects in the pizza or the late delivery of the pizza. You can talk about the softness of the pizza, the temperature of the pizza. Anything can be a characteristic. But you need to be very clear about what you have to measure. For example, when we talk about lead time, order to delivery lead time, if you really want to be specific and concrete, you need to be very clear from where to where. Because there is something called as order lead time. How much time do you take to order? There is something called production lead time, how much you take for production. There's something called delivery lead time, how much you take to deliver. So, if you talk about features of operational definition, you must be very specific and concrete, and it must be measurable. So this definition, this measurement should be useful to you and your customer, because you can't measure something which customer doesn't care about it. So it depends upon what problem that you are trying to solve. If operational definition is clear, develop a sampling scheme. Now we are going to get into how to do a sampling. There are many times when collecting all the data from a process, is it possible to collect all the data? For example, if you are launching a soap, okay, you want to launch in India. There are 130 crore people in India. Do you think you can collect all the data? No. There are many times when collecting all the data from process isn't possible. So it can be impractical, too costly, too time consuming. Sometimes you had to collect destructive data also. For example, tasting is also a destructive data. For example, if you have a piece of biscuit, you want to taste the biscuit, you have to consume that biscuit, right? And even in many of the manufacturing also, there is something called a destructive testing. So you cannot destroy everything to test 100% of the data. So sampling means collecting only some of the data. Okay. And this is a very important statement. Statistical methods. This is a very important word that I'm introducing now. Statistical methods allow us to make sound conclusions about the process, even from a relatively small sample. Okay, the statement must be, this is called statistical inference. Using statistical method, you do statistical inference. What it means is, you have data, you study the data, you analyze the data, and make conclusions about the data. And when you infer something, conclusion is nothing but inference. But most important thing to be noted here is, since we cannot collect all the data, we need to collect a small portion of data and talk about the bigger population. I'm introducing the word called population. Okay, it's not extrapolation. Okay, it's a inference and conclusion. Okay, population. Okay, for example, how many of you are good at cooking? When you make a piece of porridge, you taste a little bit and say that, oh, the whole tea is good, right? Porridge is good. If you want to make coffee for 20 people in your house, somebody has come to your house, you want to make tea or coffee, you don't taste you taste a sample, safely infer from the sample. So similarly, in production also, you have to rice cooking. Best example is rice cooking. You take a simple, some piece of rice, cooked rice, and you see that and you say, okay, the whole place is cooked. Even in baking, you don't check. You check one piece, whether it is baked okay, everything is okay. Similarly, even if you make components in the shop floor, you can take samples and represent. But there is a risk in that. Will it be 100% representative of the sample? Will it be, can you say with 100% confidence that whatever sample is, the whole is a representative of the part? No, it's not possible, right? It's a fair representation. There will be some deviations, right? With what percentage confidence can you say that whatever you're concluding is representative of the whole? For example, if you take the cooked rice, I can say with 99% confidence that the entire rice is representative of the cooked rice that I have taken. I can say with 99% confidence that the coffee or tea that I've made, which I've tasted, is a representative of the whole, the same. And so, in many aerospace industries, aerospace and medical, they want 99% confidence. Okay? We are going to talk about the p-value later. I'm just throwing some words, okay? So that you don't get scared later. So, you can say with 99% confidence or 95% confidence. You can give 1%. Aerospace and medical, they say with 99% confidence that the rice will be okay within a particular band. Okay. For example, if I'm measuring this pen, okay, and I have produced some 1 lakh pens and take 100 pieces of that, and I measure the diameter of this pen, probably if the diameter is 10 plus or minus 0.1 millimeters, I can say with probably 95% confidence that based on the data, I can say the diameter will be something like 9.5 to 10.5. So I just want you to get a feel of what I'm talking about. If you're getting a feel, just type yes, felt, F-E-L-T in the comment box, okay?